Assalamualaikum warahmatullahi wabarakatuh. My name is Aisha Zulaika. I will explain about how to find a volume of solid revolution by using these three methods, which is this method, washer method, and shell method. Okay, so I will explain to you about this method for dx first. Okay, for the dx, it is a revolution about the x-axis. We must know that there is no gap between the shaded region and the revolving line. We also must refer to the revolving line. Why? Because maybe it has some value on it, and we need to know the formula for the integration. It is dx or dy. We must remember that in this formula, we need to know the radius value, which is the top and bottom. We can get the top value and the bottom value from the question. For the boundaries, for the upper boundaries for this method, for dx, it is on the right, and for the lower boundary, it is on the left. You can also get this value from the question. And this is the formula of this method of dx. For dy, which is the revolution of the y-axis, this is different between dx. We must refer to the revolving line of x, and the radius is right minus left. For the upper boundary, it is on top, and for the lower boundary, it is at the bottom. Here is the formula of this method for dy. Okay, so next I will explain to you about washer method. For the washer method revolution about the line y, it is a dx. We need to know that there is a gap between the shaded region and the revolving line. We also must refer to the revolving line value and know the formula for this integration, which is dy or a dx. We need to remember the value of the radius in this washer method. It is a top minus bottom. For the boundary, for the upper boundary, it is on the right, and for the bottom boundary, it is on the left. Here is the formula of the washer method. It is same washer method for dy, which is a revolution about the x-axis. But for dy, we need to refer to the revolving line of x, and for the radius, it is a right minus left. For the boundaries, upper boundaries is the top, lower boundaries is the bottom. Here is the formula of washer method for dy. So here is the last method for volume of solid revolution, which is shell method. For the shell method for dx, we must know that there is a gap between the shaded region and the revolving line. We also have to refer to the revolving line because it may have some value, and we need to know the formula for the integration. It is dx or dy. We must remember, in this formula of shell method, there is no radius, but it is used cx and drx. For the cx, it is top and bottom. For top minus bottom. For the top value, we can know from the question, and for the bottom value, we also can get from the question. In this shell method, we need to know that the boundaries belong to x if we use it for dx. It is for the upper is for right, and the lower is for left. So how we want to know the rx value? Okay, as you can see in this example, for the first one, rx, if the shaded region is at the right of the revolving line, we must use the x minus k, which is the x is belong to the shaded region and the k is belong to the revolving line. It is different when the shaded region is at the left of revolving line. We must use the formula r equal to k minus x. It is same for shell method for dy, which is we must refer to the revolving line of y. In this shell method of dy, we also must know that cy is a right minus left, which is we can get the value from the question. We also must know that the boundaries belong to the y, and the upper boundaries is for the top, lower boundary is for the bottom. Here is the formula of shell method for dy. Okay, so how we want to know the ry value? Okay, so for this ry, we can know that when the shaded region is at the top of the revolving line, we need to use the formula r equal to y minus k. But when the shaded region is at the bottom of the revolving line, we must use the formula r equal to k minus y, which is y is belong to the shaded region and k is belong to the revolving line.
Hi everyone! Now, I want to show you a problem statement. Winter has arrived and Mr. John's house was also affected. Mr. John and his family planned to clean the pool in their backyard, but the water in the pool was completely frozen. So, Mr. John's son suggested that they need to release the frozen water. They have to figure out what is the total volume of the frozen water so they can estimate the right place to dump it out. Consider that the Mr. John's total pool's areas as the diagram showed. Next, consider that the Mr. John's total pool area as the diagram showed. Next, we move to the question. Question 1 is, how much volume of the frozen water generated in the pool when the pool area is revolved about the line y equals to 1 by using this method? Next, question 2 is, how much volume of the frozen water generated in the pool when the pool area is revolved about the x-axis by using shell method?
In this part, we need to calculate the volume by using this method and shell method. Okay, this is the first question by using this method. Okay, the first one, we need to figure out the clue from the question. Okay, the clue is y is equal to 1. So the clue is dx. We want to use dx. And then we figure out top and bottom. This top and bottom. Okay, so top is x to the power of 3 and bottom is 1. We need to use that to find the radius. So the radius is x to the power of 3 minus 1. It is because top minus bottom to find the radius. And then we need to find the upper boundary and lower boundary. From the figure 3, okay, we can see the upper boundary is 1, the lower boundary is 0. And then after we have the information here, we need to know the volume of, we need to know the formula of this method. This is the formula volume of this method. Is pi x is equal to a when it's reaching to x is equal to b radius square dx. So pi x equal to 0 is lower boundary and the upper boundary x is equal to 1. So this is replaced with our actual radius x to the power of 3 minus 1 square dx, and we solve in the bracket here. We got x to the power of 6 minus 2x to the power of 3 plus 1 dx, and then we integrate this dx here. We got x to the power of 7 over 7 minus 2x power 4 over 4 plus x. This is the value of x. This is upper boundary and this is the lower boundary, and then we just replace the x value, lower and upper boundary here. X is equal to 1. We replace here and here, and minus. We use this equation too. By minus, we replace dx with the lower boundary, which is 0, and then the final answer is 9 over 14 pi unit cube. Okay, the second question is we need to use the shell method to get a volume of this shaded region. We need to use shell method. Okay, this shell method we need to figure out where we need to have where we need to have the volume. Okay, this is the volume for this is the formula for shell method. 2 pi y is equal to a until when it's reaching to y is equal to b ry and cy dy. This is because we use dy. This is because revolve the x-axis here. Okay, so when we use x-axis dy, we have a clue of dy here. Alright, and then we'll just replace the ry. When we need to use ry, okay. This is ry because y is equal to 0 here. Y is equal to 0 here. We start with 0 here, and then we start with 0 here, and then the shaded region is on the right. So y 0 will come here, and y is minus 0. So ry is y minus 0. Okay, we need to use ry in this formula, and then we need to use cy in this formula. Cy is top minus bottom. Okay, we know the top is minus bottom. Okay, so bottom is 0, and then the top is, after we make solution here, we got y the power of 1 over 3 minus 0. We got the cy just y the power of 1 over 3 here, and then we solve here. Y dot ry dot cy here, we got y the power of 4 over 3, sorry, and then we integrate here. We got here 3y the power of 7 over 3 over 7. This is y is equal to 1, y is equal to 0 is because the upper boundary here, and this is because the right, and this is because the left. Okay, this is upper boundary and this is the lower boundary. Okay, after that we replace the y with the value of y here, 1 here, and minus the same equation, right? Just replace the y with 0, and then we got the final answer is 6 over 7 pi unit cube.
For the question A, the answer is 9 over 14 pi unit cube. Because there is no gap between the revolving line and the shaded region, we use this method to solve this problem. By using this method, we got the exact same answer, which is 9 over 14 pi unit cube. As for the question B, the answer is 6 over 7 pi unit cube. In this problem, there is a gap between shaded region and the revolving line. So we can use the same method as question A, which is this method. So we came up with a proper method, which is shell method. By using this method, we got the answer, which is 6 over 7 pi unit cube. Solution, we can conclude that our objective is accepted. It is because this solution that we used to find the volume is succeed. Also, by using this method and shell method, we can apply it